solve the absolute value of x over x plus 1 is greater than or equal to a half. So our first choice of method here would be to square both sides since everything is positive. And doing that, we're going to get x over x plus 1 all squared is bigger than or equal to a half squared. So x squared over x plus 1 squared is bigger than or equal to a quarter. Multiplying through this algebraic fraction, I get 4x squared is bigger than or equal to x squared plus 2x plus 1 when I expand this, which means 3x squared minus 2x minus 1 is bigger than or equal to 0. I can factorize this into 3x plus 1 minus 1. Now, thinking about that, it's a quadratic inequality, so I need to think about what the graph looks like. It goes through at positive 1 and minus a third, so it's going to be something like this. When is that positive? It's this value's here and this value's here. So that is when x is less than or equal to minus 1/3, or x is greater than or equal to 1. So that's the first method, by squaring both sides and solving a quadratic inequality that comes out of that. The second method is to think about what the graph of this looks like. We're going to do a little bit of rearrangement first to get to something that we can graph more easily. We could try and graph this, but we'll graph something that's a little bit easier. So first of all, using some of the rules of absolute values, this is the same as the absolute value of x over the absolute value of x plus 1. And then multiplying through, we're going to get 2 lots of the absolute value of x is greater than or equal to the absolute value of x plus 1. And this is the same as the absolute value of 2x is greater than or equal to the absolute value of x plus 1. So now we've got 2 linear functions that we're taking absolute values of, which is a bit easier to handle. Let's think about what these look like. First of all, the absolute value of 2x. Well, 2x is a fairly steep line going up like that through the origin, and then it bounces up on this side from the absolute value. And the x plus 1 is going to go through here, and then it's going to hit over here, and then it's also going to bounce up, but that doesn't really matter because all the points of intersection on that side are going off. They don't intersect anymore. We've got 2 points of intersection, which are these 2 points here. Once we've found those points of intersection, we're interested in when the red graph is bigger than the blue graph. So that is these values here and these values here. Let's first of all find those values though. So those values happen, looking at this one first, that's the positive 2x is equal to the positive x plus 1. So subtracting the x on both sides, we get when x is equal to 1. Or, for the inequality, we want it to be x is greater than or equal to 1. The other part is when the negative of the 2x is equal to, it's still the positive of the x plus 1. When we add the 2x, we get 3x is equal to negative 1, or x is equal to minus 1/3. And the inequality then, we want to the left of that value, so we want x is less than or equal to minus 1/3. And we get the same answers as the quadratic method. As I said before, it's your choice which one you want to do. This one involved a little bit of algebraic manipulation before we could draw the graphs. Some people prefer this graphical approach. Some people prefer the square both sides and work through the quadratic inequality.